So this experiment is found on page number 64 in your lab manual, and it is looking at the effect of molecular weight on diffusion. So what we did is what we would do in lab if you were in there in person is we would take a Petri plate like this, which has some agar inside it. It looks like this. It is a, you can see the material in the inside right here. This material is like jelly-like, like jello structure, like a jello-ish material. It's a little thicker than jello. It is usually used, these types of plates is usually used to grow bacteria. We usually have some sort of nutrients in it, and the bacteria will grow on these plates. But for our lab today, we're going to look at the effect weight has on diffusion. So we know diffusion is the movement of a solute or molecule or gas from an area of high concentration to an area of low concentration. So what I did is what the lab says to do, is to punch 4 holes in your agar, which is that jello-like material. You're supposed to punch 4 holes using a cork borer. So I already did this, so I took it and I punched the holes inside there. And then it asks you to fill the holes with methylene blue. So methylene blue is a dye. We used methylene blue in the lab number 3 when we stained the cheek cells, you remember? Methylene blue has a weight. It has a molecular weight of 320. So the molecular weight of methylene blue is 320. So we're going to do what the lab book says, which is to fill the holes with methylene blue. So make sure they're full. And then we're going to fill the other holes with potassium permanganate. So potassium permanganate has a molecular weight of 158. So this is 158. So knowing that the methylene blue is 320, has a molecular weight of 320, and the potassium permanganate has a molecular weight of 138, you can kind of already have an idea of which one is going to move faster. So what we're going to do is we're going to take a measurement. We're going to take diameters of, we're going to cover this, and we're going to start off with the diameters. And we're going to place the Petri dish and replenish the chemicals in the holes after 15 minutes. You're supposed to measure the diameter of each circle in millimeters after a total of 40 minutes. So we can measure we can measure the hole actually in millimeters. We can measure those. And then after 40 minutes, we're going to go ahead and we are going to measure how much they moved. We're going to cover this. We're going to leave this and check on this every 40 minutes, every 15 or 20 minutes to check to see if I need to replenish the liquid that I placed in it. So we will be back with results. So we are going to go back and check our results. And I measured the bore to see the holes. So all the holes are the same length. They're about 4 millimeters in length. And then now if we go and we measure from how far they've gone out, you can clearly see which one moved the fastest. You can see that potassium permanganate, because of the purple circles around it, moved the fastest, and the methylene blue did not move as fast. So if we take our ruler and we measure, it moved about, see the diameter, it moved 5, 10, almost 15 millimeters on this side and the same on this side. And the methylene blue only moved a little bit. So if you go to your data table in page number, go to our data table 1, it tells you circle 1 diameter and circle 2 diameter. So for this one, we can safely say that the diameter of this one is, let's see, 5, 10, 13, and the same about here, about 13. And the methylene blue, it moved about 5, maybe 7 millimeters on both of them. So for that table, for page 68, you were going to write in circle 1, and circle 2 is 15 in potassium permanganate, which is that KMN04 number. And then for the methylene blue, you'd put 7, and then you're going to take the average. And then it's going to ask you which substance diffused further, the potassium permanganate or the methylene blue. Well, you can clearly see from here that the potassium permanganate moved much faster. And the reason is this is because the molecular weight of potassium permanganate is 158 and the molecular weight of methylene blue is 320. And this is what relationship can you state between the molecular weight of a substance and the rate of diffusion? So the smaller a substance is, the faster it's going to move across, a system. So if it weighs less, it's going to move faster. So we could say that it's directly proportional upon size. So that is for exercise part 1, passive transport. This is where you're going to put your measurements for the potassium permanganate and your measurements for the methylene blue. You're going to state which substance diffused further, potassium permanganate or methylene blue. And then you're also going to state what the relationship is based on the weight of the substance, which moved faster and which moved slower. And you're going to give a reason why.